All right, ETH Brussels 2024. My name is Eric Bishard. We are going to get started with the MetaMask and Linea React workshop. I can't wait to see everyone in Brussels in 2024 in July. And we have some great bounties for you for MetaMask and Linea. So unlock secure, seamless blockchain experiences with MetaMask and Linea, your gateway to dApp innovation. So we're offering a $5,000 bounty for dApps deployed on Linea and seamlessly integrated into MetaMask with the MetaMask SDK and snaps. $2,500 for first place, $1,500 for second place, and $1,000 for third place. So all you really need to do to apply for the bounty is to either build a dApp on Linea and use the MetaMask SDK for React and WAGMI or Web3 onboard. You can use any of our versions of the MetaMask SDK in your front end, as long as you're deploying on Linea. Or you can build a MetaMask snap that reads from and interacts with any type of smart contracts deployed onto Linea. So that's all, one or the other. And what we're going to do here is we're going to cover a workshop that kind of gets you set up for that first option. If you want to know more about snaps, visit MetaMask docs. You can even contact us, find us out at the hackathon, and we can put you in touch with someone from snaps. But we have lots of documentation for snaps. But today, our workshop is going to be based around MetaMask SDK and Linea. We're going to be building a Vite, React, TypeScript demo application. And we're going to be using Solidity, again, the MetaMask SDK, Infura, Foundry, Cast, and we're going to deploy that to Linea. So I'm going to run through just a couple of quick slides here. Now, my name is Eric Bishard. I'm the Developer Relations Manager at MetaMask. You can find me on Twitter, Telegram, GitHub, Lens.eth, probably some other places too, like Reddit, at HTTP Junkie. So that's how you can get in contact with me. I'll be there with all of my DevRel colleagues to help you out. We'll be there during pretty much the entire hackathon. So my DMs are always open. Just reach out to me. We pay really close attention to Twitter and Telegram while we're there. What does the MetaMask SDK do? It allows your dApp to connect to the MetaMask browser extension or MetaMask mobile. In the demo that we're going to be doing today, and I'll talk more about that in just a moment, we are going to be using it in conjunction with a Vite.js application, VM, and WAGMI. But there are other options. You can use the SDK on its own. You can use the SDK with a multi-connection library like Web3 Onboard. And soon, and possibly even before Brussels, there might be some other options. So you can always come and ask us about that, and we'll try and get you squared away. But I think most people are going to want to use it with WAGMI. And this URL right here is where you're going to get to the page that I'm about to show you once I exit out of these slides. And basically, it's a GitHub repo. There is a README there. During the workshop, I'm basically going to be walking through that README and building the workshop from scratch right in front of you so that you get to see every aspect of the entire thing. I think that's the best way to wrap our head around around the entire thing in less than 1 hour. I'm going to try and keep it less than 1 hour, but know that you can always just clone down that app, and there will be instructions in that README to basically npm install the dependencies, deploy your contracts to Foundry or with Foundry to Linea testnet, and then change into the web directory and run npm run dev and have it working. So we'll get to that in just a moment, but this is the link that you would want to go to find those resources to basically download this starter application, which you can do whatever you want with, but we think it's a great kind of starter application, very minimal contract work in there, a very basic front end, but also working with WAGMI, working with the MetaMask SDK, allowing you to connect to extension or mobile for MetaMask, deploying to Linea, using Infura, using Foundry. We asked a lot of developers, you want us to use Hard Hat or Foundry in the next workshop? And it was a resounding Foundry, Foundry, Foundry. We've done workshops in the past with Hard Hat. Plus, we believe that a lot of the hackers out there have experience with hard hat more than Foundry, but there is a shift going on, so we're going to do it with Foundry. So LFG, let's go ahead and get started. So the page, that tiny URL that I just showed you will take you to this README. This might change a little bit before Brussels, so if it looks a little bit different, no worries. Just know that if you read kind of like the beginning of it, you're gonna have clear instructions on either how to build the entire thing from scratch yourself or how to clone down this repo and how to get it deployed to a testnet and get it running. And then you can use this application kind of as a reference to know how all these things work together. Now, some of the hackers might know how to do all this, but we want to kind of make something, this workshop, in case there are people out there that are new to some of this. Maybe it's your first time hacking at ETHGlobal. We want to cover all bases. So if you're well experienced, download, clone the repo, look around at it, specifically how to use WAGMI with MetaMask SDK, which is fairly easy, but we're going to go on a deep dive for those who want to learn a little bit more. I'm going to pull this page over to the other side of my screen over here. One thing that we're going to do right when we start the workshop, we're going to be using this little CLI tool that my team created. This is nothing that's supposed to compete with anything else out there. It's just a tool that we built to help hackers get started. But I think that's also another really interesting thing that you can look at is we have a CLI that you can either pick Next.js, Vite.js to build something with Hard Hat or with Foundry, and it basically scaffolds out this mono repo for you and gives you a nice starting point with the MetaMask SDK already wired up. So if you're entering our bounty, definitely use it. But if you want to use it for something else, you can rip stuff out of that and make it your own. And it's very basic. And then we're going to take that a step further and build some stuff into it. Put Solidity contracts into the blockchain folder. Throw some components into the web React directory and basically build some stuff. So let's go ahead and get started. I'm going to move this out of the way and just kind of over to my other screen over here. And I'm going to be following this kind of README as we go. And I guess the first thing that we need to do is we need to clone down this repository. So let's go ahead and do that first. So I'm going to have kind of that over to the side just in case. Just in case you need to take a look at it. But what I want to do next is I'm going to create in a separate folder. So I want to have that there just in case we need to reference it for anything. Hopefully we don't. Hopefully we don't have any problems. But what I'm going to do is that repo that I just showed you, I'm going to show you how I built it from scratch. Actually, me and one of my partners built it from scratch. So what we're going to do is we're going to use that CLI that I told you about. So let's go ahead and get the command for creating that application here. Basically using that CLI to scaffold out an application. So we're going to use npx, and we're going to use this consensus create web3 template. And we're going to call our project my web3 project. It doesn't really matter what we call it. So we're going to go ahead and do that. And now you're going to see that we can choose from Next.js Web3 Starter or React Web3 Starter. Now, both of these are going to give you a hard hat mono repo, whereas this one down here is going to give you a Foundry one. And hopefully we'll have some of this kind of updated by then. We've just built a lot of this stuff, so it's not perfect, but you might see some different options here when you run this. But know that you have these options. And if you want to use Foundry, go with the one that says Foundry. If you want to use Hard Hat, go with the other two. So we'll go ahead and click that. And so what that's done is it went ahead and scaffolded out a project for us. And we can CD into that by doing my Web3 project. And what I'm going to do is I'm going to CD into that directory, and then I'm going to open up in Visual Studio Code. We'll pull that over, and we can get rid of this guy here. All right, kill that, open up our terminal. I use NVM, so I just want to make sure that I am on the version that I want to be on. 20, great. And so now the next step, if we go into our package.json here, you will see that there's an install Open Zeppelin script in here. What this is going to do is, we know that a lot of people want to use Open Zeppelin, whether it's Hardhat or Foundry that you're working with. A lot of people want to install those Open Zeppelin contracts. So what we're going to do from the root of the project is we're going to run npm run install Open Zeppelin. Now, this is my first time doing this. It'll be great because if I run across any little issues, I'm going to work them out right here in front of you. I think it's going to be great for you guys to watch the entire workshop. It shouldn't take long, and I think you'll just learn quite a bit. One thing I want to do real quick is our CLI sets you up with the basic counter.sol. So we're going to delete that. I'm going to move that to the trash. We see our lib directory there. That's where it copied all of our Open Zeppelin contracts into there. And the first thing that we want to do is inside this source directory here, we want to create 2 new files. So one of them is going to be called example nft.sol, and the other one that we're going to create is going to be called voting.sol. And I'm going to copy in some basic Solidity code here, and we'll walk through it a little bit. This course is not to teach you Solidity necessarily, but we'll walk through kind of a little bit of what these contracts do, and give you kind of the idea that we came up with. One thing I'll tell you is the idea that we came up with for this kind of resource application, this demo for you guys, is that we wanted it to have a couple of contracts in it. We wanted to have a web dApp that will interact with these contracts, and we wanted to cover a few edge cases like when I mint an NFT or when I vote. I don't want my user to have to hard refresh the React application and all that kind of stuff. So as we go through the web application, we'll show you these different things that we built in, how we got the SDK to work with WAGMI, the things that we did with the WAGMI hooks in order to be able to refresh, to be able to read contract and then to be able to recall once the transaction is to complete, to be able to kind of recall that function again and get any changed data that we have. So let's start with the example NFT. Let's go back to terminal here, and let's just walk through these really quickly. So it's pretty simple. We have the ownable SOL so that we can basically, so the ownable contract makes it so that we can specify kind of the owner of a specific contract by passing an address in. We have the ERC 721 URI storage, base 64, so that we can encode a basic SVG. Our NFT is an SVG NFT because we didn't want to build a workshop that requires you to, host files on IPFS and do all of that file management and stuff. So by having an SVG as the NFT, it's kind of built into the contract. When you mint it, it's there, it's on chain. Yes, that is a little bit more costly with gas, but again, this is a demo and it's the easiest way to kind of get right to the meat of everything that we want to do. So we've got our basic little SVG here. It is nothing special. It's just a white SVG. It prints out some text on it and your address, and that's about all it does. But again, this is a demo. We've got this get tokens by owner. So we want to be able to call from the front end, and we want to know how many NFTs basically does the person with this specific address own? How many have they minted? And then we also want a safe mint function, right? So not a whole lot going on here. Now there's a voting.sol, and what this is, we're not really going to cast a vote, but what we're going to do is, the idea is to make sure that we have this gated voting system, which we're basically just kind of signing, but it's a gated kind of voting system so that the user needs to have an NFT first before they can vote. Now, a few of the things that you could do to take these contracts a little bit further is and build in additional functionality. You could build in the checks to make sure that someone's actually minted an NFT before they can vote here in the contract. We actually do that on the front end. But the whole point of the demo is just to basically deploy some stuff onto Linea to show you how to do that and then to interact with those contracts. So we didn't want to make the stuff too complex. We wanted to do just very, very basic Solidity contracts in here. All right. One other thing that we need to do now that we have these kind of contracts in place in the blockchain directory is from the root directory, we never did our dependencies. We didn't install our dependencies. So let's go ahead and do that real quick. And while that runs in the background, I'm going to move on to the next thing here. So at this point, it looks like we've got our node modules installed in the root of the directory, in the blockchain directory, and also in the site directory, which is our React application. So we're good to go there. I also want to cd into the blockchain folder, and we're going to run in the README. There is instructions if you don't have Foundry on your computer on how to do that. Also, I'm using Cast, so I've stored my wallet information so that you don't see that like my private key on screen. And I've also stored my Infura API. We have all that instruction in that README if you want to know how to do that. If you're working with other people, if you're working in front of people and you want to be able to obfuscate that stuff, there's instructions in there. So you might see some of that, but just know that we've got everything covered in that README. We're going to run forge build right here in the blockchain directory and just make sure that our stuff compiles. What do we do here? Let's back up for a moment here and just make sure that we ran the npm run install. Let's do this again. I think that's the problem. I don't know why this wouldn't have worked, but I'm going to run npm run install OpenZeppelin again from the root. Let's also just run pnpm install again. I don't know why that wouldn't have taken. And we've got the example NFT and voting in the source directory here. Gotta love the demo gods. All right, so maybe we just need to go ahead and deploy our contracts. Let's try that really quickly. Never had this error right here before, but I'm going to run forge create. I'm just going to go right into it. So forge create, I got my RPC URL. I've got my Infura API key in here. I've got my account, Eric B-test. Okay, I just took a pause there and I got it working. The issue was that I had basically an argument in the ownable right here, which shouldn't have been there because the owner of the contract is set to the deployer by default and we don't need to pass message.sender. How I got that in there, I'm not sure. It might have been something I copied over, but I have updated the README to make sure that you don't copy in any code that doesn't work. So our contracts have built the example NFT and the voting.sol, And I saved you me Googling and figuring something out real quick and then realizing my typo. But let's go ahead and move on. So kind of the next step that we want to go through here is we want to go ahead and deploy our contracts out to Linea. So you're going to find these commands right in the README. So let me run forge, create, we got our RPC URL with our Infura API key. Again, I need to fix my name of my cast wallet name here, and then that should be good. And let's go ahead and deploy that. And it will ask me for a password. And then what we're going to do is we're going to create a .env file, and we're going to put that in our packages site. So we'll just click here and do new file, .env, save that. And we're gonna create a few environment variables here so that we can use throughout our application. And we want to copy this deployed to address. And so we want our front end to be able to use that by using this variable name right here. And then we'll do the same for the voting application. So do forge create again. And let's just make sure that this is all right. I've got the right account name that time. And then you can see at the end, this constructor args, if we look back at our voting, it needs an argument for basically the public address. So we'll go ahead and run this. That will deploy it. Got to put the password in again. Hope I typed that in right. All right. So we will copy that deployed to right here. Copy. And again, we'll paste that into our environment variable here. And now we can use those throughout our application. Great. So the next step is basically everything with the blockchain directory is done. We've got our contracts in here. We've deployed them out to Linea. If you don't have an Infura API key, you can sign up to Infura for free and get a free account, which allows you to have one project, and that will give you an Infura API key. And then again, you can create an alias. That's what I've done in ZSH that equals that API key. And then you can set like a wallet up with your private key with cast so that you can just plug those into your Foundry commands. And again, all of that is covered in the README. Now, when it created the site for us, it went ahead and gave us a components connect button. And this is actually correct for the most part, but I wanted it to look good. So I've added a little bit of styling. And yeah, I don't think I've added anything other than styling here. So I'm just going to copy this in. It's going to look very similar, but it's going to have some tailwind styles in there. See those? So that it looks pretty on the page. We need to create another component in here. So all this is a connect wallet button and a disconnect wallet button. And what we're doing here is since we have set up we kind of do this for you with our CLI, but you could also do this by hand. So we've set up the MetaMask connector and just added some values in here. We've told it that we want to use Linea Sepolia. If you want to get Linea Sepolia, you can go to the Infura site and there's a faucet. Another thing that you can also do is Google has a Sepolia faucet. You can probably find other regular Sepolia faucets, and you can go to the Linea site and bridge those over to Linea Sepolia. So, or you can come up to me in the hackathon and ask me, and I'll send you some because I got quite a bit of it. So that's pretty much all the configuration we have to do there. Our our main.tsx is already set up with the TanStack React query. We're not going to go over this too much, But I guess what I could tell you kind of about this main.tsx here is, let me get to it here because I've kind of made some notes for this. Control F, main. Here we go. So you've got your imports up there, basically your WAGMI provider, deserialize, serialize, persist query client provider from TanStack. You've got create sync storage persister. So kind of what do these things do? The query client configuration basically creates a query client instance with custom default options. So GC time sets garbage collection time for the query cache to 24 hours. Network mode uses offline first strategy for queries and mutations. Refetch on window focus disables refetching queries on window focus. It's pretty evident. Retry disables retries for failed queries. And then you got your persister configuration. This is all kind of stuff you learned when kind of setting up and using TanStack query. The key defines basically the key for storing cache data in local storage. Serializes functions for WAGMI. Storage uses window.localStorage for storage. And deserializes is a deserialization function for or from WAGMI. And then basically we're rendering our application here. We're setting up our WAGMI provider, which we pass the config into it, which we got back from our last page we were just on. And then we're using this persistence query client provider React context. If you want to know more kind of about the intricacies of like TanStack query or even like the WAGMI provider and how all this stuff works, open up ChatGPT, throw in the WAGMI config, throw in the main.tsx and say, hey, ChatGPT, explain this to me. But a lot of you probably already know kind of how this stuff works. We also need to create another component here, and that component is going to be called, we want to do this one, SVG card, and we're going to call that .tsx. And this is a pretty simple component that we're adding here. So what this is going to do is it is going to basically read the contract. It's going to we're going to basically pass it an address or a token ID, and it's going to know kind of which SVG that we own, and then we're simply just printing that SVG onto the page by using the token, the SVG token ID. It's fairly simple. Basically, we're able to fetch that SVG as it exists kind of on the blockchain, and then with this image tag here, we're then rendering it. What's up with our utils.abis? Yeah, we don't have our ABI in here yet. I'm going to copy in the ABI so you can find the ABIs inside your blockchain folder. What I like to do is kind of format that out a little bit and create like an export const in a TS file that's called like NFT ABI, and then paste in all that JSON into a JSON array. So what I'm going to do is I'm going to create inside the site directory here a new folder called utils. It's just what I'm calling it. Let's see. And do that again here. New folder, utils. And here I will do a file called, what did I want to call this? I think it's NFT ABI is what I'm calling it. abis.ts. So new file, abis.ts. And then I'll just paste that in there. It's a very big file. Again, all this JSON comes directly from the when we compile the contracts out. However, what I like to do is just kind of format it because it's all jumbled in as like one big JSON file, and that's not easy to read. And sometimes I want to come in here and just make sure that, you know, what does a function take and that kind of thing. So with that in place, let's make sure that it's pointing to the right place. We got utils, ABIs. Let's make sure this is going to the right place. utils NFT ABI. Oops. Utils ABIS. There we go. NFT ABI. Oh, no, we just need ABIs like this. There we go. Isn't that what we had? Interesting that it wasn't showing up. But anyways, it's there now. Moving along. We're actually pretty far through this. The next thing that we need to do is we need to create our app.tsx. And this is the one page that when I'm gonna come in here and replace all of this with a bunch of code, and we're just gonna walk through it really quickly. So if we take a look at it from the top, you can see we have all of our imports. We've got use account from WAGMI. We have connect, which is from the connect button. We have the NFT ABI and vote ABI. These are the functions coming from the smart contract. And then we have use read contract, use write contract, and use wait for transaction receipt. So these are all functions, the last ones that I just read, these are what we're going to be using to basically read and write to the contract. And then the use wait for transaction receipt is what we're using to be able to get refetch. And refetch, the basic kind of way to think about this is sometimes whenever I mint an NFT and then I want to go and get the NFTs that the user owns and display them on the page, often, or most of the time, if you don't kind of use wait for transaction receipt and refetch, you're going to need to your user's going to need to refresh the page, and then some of the code's going to have to run again. And we don't want that. We want it to have a better user experience. So as we move down to kind of our state, our local state for this component, we have is connected an address from use account. So this is a hook to check connection status and get the user's address. Again, they'll be connected with MetaMask, so this will be available to us through the WAGMI hooks. We have has voted and set has voted. So this is just state to track if the user has voted or not. Again, we're checking that on the front end. If we were building a real application, we want to build all of that into the smart contracts and make those a little bit more kind of built out. So use write contract. This is what we're going to use to interact with the smart contracts to do write operations. Use wait. Use read contract will be obviously to read data from the smart contracts, and then use wait for transaction receipt to wait for the transaction to be mined in the case of like minting. We also have some variables. Let's see. Let's go to the other one here. So when we're kind of using the use write contract hook, we want to be able to get hash. Write contract is success from use write contract for minting our NFTs and voting. And then we have result right below it. We're basically calling the return of use wait for transaction receipt and giving it that hash, and the result holds the transaction receipt result. Then we have voted when we're using the read contract in order to call basically the voter method or the balance of function from the either the voting contract or the NFT contract. And then below this, we have basically use read contract. Here we are getting the tokens by owner. So this will return to us the data that we need in order to know what tokens does a specific address hold. And then with that, we'll be able to kind of iterate over those token IDs, get that SVG NFT and print them out on the page. You'll see that we have this use effect here, which if they have voted, and we're going to see all this working in just a moment, then we're going to set voted to true. This is very, very basic. But this is the part right here that I would have you look at. If we did not have this use effect here, and if we were not getting refetch and kind of giving it this name, I'm giving it a name for each one. So refetch token IDs by owner. We have refetch user balance. That user balance is actually the number of NFTs that they have, and then this refetch voted to know whether they voted or not. If you did not have these and call this refetch upon the result being true, or kind of the result being completed for each of these actions, then when you mint your NFT, once you've minted your NFT and you're allowed to vote, kind of this token gated voting, once you've voted, or also that we have another button on the page that will add those NFTs to your MetaMask. Once you finish those operations, the page wouldn't refresh and show those things. So that's what we're using these for here. Beyond that, we just have the basic mint NFT and vote. And of course, these are write operations, not read operations. So we're writing to the contract using the safe mint function. Everybody knows what that is if they built an NFT contract before, and the has voted function. This final method here is for adding an NFT. So once we have the NFTs on the page, whether we have 1, 2, or 3, no matter how many you mint, you can, with one button click, you can add all of those SVG NFTs to your MetaMask. And we do that by calling the MetaMask API wallet watch asset. This is something you can only do with MetaMask for the most part. And we're telling it what kind of an NFT it is. We're telling it what the address of that contract is. And we're also giving it the token ID. And through all of those things, MetaMask is able to figure out, okay, here's the NFT on chain. It doesn't work on kind of testnet, but it works on mainnet. But we still want to have this functionality in here. Or I should say, it doesn't work on every testnet. It really depends on how the testnets are set up. But this will work on all mainnets. So if you have this deployed to production and someone mints an NFT, your MetaMask doesn't know about that NFT. It's the same thing if you kind of import some token, or you get some token that MetaMask doesn't know about, and you need to import that token. Wallet watch asset is the same API call that you do that with, but you can do it with tokens or NFTs. This function works for both of those. And then beyond that, we just have our connect button, we have our mint button, we have our add NFT button, we have our vote button. These are the things that call those functions. And then finally, we'll be iterating over those token IDs by owner and mapping them out and then printing the SVG for each one of them. So with all this in place, let's stop kind of messing around. Let's see, do I need to do anything else here? One thing I'm going to do really quickly is in my TS config, I'm going to update this. And so what we need to do here is we need to add the paths, right? So we added this paths. So this just sets up an alias that I can use for importing stuff from the blockchain out folder. And then this is just kind of mapping source to, so that we can, let's see, how do I explain this? So the purpose for include, this kind of include array that we see here that we just added or we modified, this include array specifies the files and directories that TypeScript should include in the compilation process. So this is just basic TypeScript configuration stuff if you have never seen that before. And about the only thing left that I want to do here is I want to update. I want to update my get ignore file too, because I probably want to potentially upload this to GitHub, and let's not look at our node modules, get that out of there. But we definitely don't want to upload our .env, especially if you do more with your project and you put more environment variables there. And we don't want that pnpm lock.yaml going up to the to GitHub, because that's going to change anytime that you update your dependencies. But with all that, what we can do now is we can kind of cd out of this blockchain directory. Go back into my Web3 project. Yeah, that's what it's called. And then from here, we can cd into packages, site, and now we can run npm run dev. And we can cross our fingers and hope that all of the code that we copied in actually works. We're coming up on 40 minutes here. Hopefully we can get through this with no more issues. Again, the README will have everything in there. It'll be nice and neat. And you can just poke around this code. I really, really suggest that if you're new, if there's something you don't understand, create an OpenAI account, use ChatGPT, copy the thing that you don't understand, explain why you don't understand it. This will accelerate your process of being able to rapidly build things and understand things. So we're going to do connect wallet, and what you're seeing here, this is different than when you use a connect wallet button from most dApps, right? Usually when you hit connect, it opens up MetaMask right away, but it's telling us here that we can connect with mobile. So what I could do is I could open up my MetaMask mobile, and let's just go ahead and try that really quickly here. So I got MetaMask open, and I'm going to hit the little QR code feature here, and I'm going to scan it. And then it's going to ask me if I want to connect. I'm going to hit yes, or I'm going to hit connect. And then you can see here that we are now connected. And so we could start doing things. We can disconnect also. I don't know why that said already voted, but anyway, so the next thing that we can do is instead of connecting with MetaMask Mobile, we could also connect just with the desktop. Why does it say already voted down there? This might be a small little issue that I need to with my conditional rendering, but I'll fix that. So we're connected, and the first thing that we want to do is be able to mint that NFT. So we're going to go ahead and call the mint function here, and we're going to hit confirm, and boom, it mints our NFT. Yeah, I don't know why that said already voted there. It's probably my logic for rendering out the buttons. I just completed this whole workshop today, so bear with me. But my logic was probably messed up. Probably something like an exclamation point or something in the wrong place. Cool. So now that we've minted, we have the opportunity to vote, right? So what I want to do now, well, before we vote, let's go ahead and add the NFT to MetaMask. So what you see here, now this normally would be this NFT here. What happens on test nets is, I don't know exactly why, but I've seen it on Linea Sepolia. It used to work on Linea Garely. It doesn't work on, I think, Mumbai. Something with the way that they kind of, I don't know, the data and the NFTs that kind of you store on the testnet, for some reason, MetaMask isn't able to read them because the way that the testnet is managed differently than mainnet. But know that this, if you added the NFT, it actually is still adding it. It's just not adding the picture of it. It's for some reason not able to get that picture. But now if I were to go to MetaMask and I were to go to NFTs, I would be able to see these example NFTs here that I've added. And if it was on mainnet, it would show up. If this was some elaborate design, you would see that design. But just know that that's what that button does. And it doesn't really matter if it works on testnet or not, because the code that you need to do that is in the application. And that's the important part. The next part is vote. So we're going to go ahead and cast a vote. And all this really does is just record that you have voted. We haven't put any options like, this could be like, voting for, the president of a DAO, or voting on whether or not to increase budget on something. It could be anything. Voting on, who's hot or not, whatever. But all we're kind of doing is when we hit confirm here, we're just kind of writing to that voting contract and letting it know that the person, one with this NFT and this address, casted this vote, and then we have a mapping in there so that we know if they voted or not. And as you can see here, it says already voted. It won't let you vote again. We could take a look really quickly at the code and see if we can figure out why it was saying not already voted before. So let's just check this out. So if has voted, if not has voted, and the user balance is more than 0, then we want to, so if they have the NFT, because user balance is more than 0, that's what user balance means, that they have, it's the number of NFTs that they have. Probably could have named it better than that. And if not has voted, then we're going to show the button to vote. And for some reason, that wasn't true for user balance wasn't more than 0. Oh, I see. So what if we were to do this? We would have to redeploy the contract again. No. Well, I'll tell you what. I'm pretty sure I kind of know why this is, it was showing already voted here, even when we hadn't voted yet. The good thing is that it wasn't showing the button because these two things weren't both true. And if we need to update any little pieces of code, remember that we were recording this workshop 1 month before ETH Brussels. They have these, strict guidelines for us to get these workshops in. So if there are any small little changes to like one line of the code, rest assured that in the README, it will be right and the application will work perfectly. That's a very small thing, but I think we've covered quite a bit. So we use the CLI to scaffold out basically a mono repo. And I think that's kind of the one thing that you can take away from this and be like, that's really cool. I don't care about this contract thing that you set up. I know how to kind of call contracts and work with WAGME and all this kind of stuff. But hey, using that CLI to scaffold out that entire mono repo really quickly, that's pretty cool. I could use that as I get started hacking. If you can just take that away from this workshop, I think that's great. And then other than that, pulling this down onto your computer at the hackathon so that you have a resource to show how some of this stuff works if you're not familiar with it. It's great to have working code and maybe even running that, trying to run it and make sure it all runs on your machine so that if you want to kind of use it as a reference and know how to write a certain line of code or whatever, you know how to do that. And you know how to use kind of Infura with Linea, with MetaMask SDK, all in a React application with Foundry, deploy contracts, and use it with VM and WAGME. Like that's, hopefully that's super helpful for you. That's how we're going to wrap up this workshop. I hope that you got something out of it. Please come and see me on the floor. And if you see me at ETHGlobal and you've checked out the workshop, either you've checked out the repo or you've watched to this video, please come say hi to me. We take contributions to it. We'll probably have done a lot more work by then on the workshop. So we're really happy to bring this to you, and good luck hacking. And I hope you all build really amazing stuff and win lots and lots of Ethereum. So thank you so much, and see you at ETHGlobal Brussels next month.